Hello students, as in the last video we have already solved from question number 1 to 8 of exercise 5.5 of NCERT textbook of mathematics class 12. So from in this video we are going to solve the remaining problems from question number 9 to question number 18, and link of the previous video is provided in the description box. So please watch that for question number 1 to question number 8. Okay, so now let's start. Let me solve question number 9. So here consider this one is u and this one is v. This is u, this is v, suppose. Then so let u is equal to x to the power sin x. So taking log on both sides, we get log of u is equal to log of x to the power sin x, and we know that log m to the power n is equal to n into log of m. So using that rule, here we will get log u is equal to sin x into log of x. So now we can differentiate with respect to x. So differentiating with respect to x, if you differentiate with respect to x, log u gives 1 by u into du by dx. On the other side, here you have to consider this one as first function and this log x as second function. So here we are going to apply the product rule, u into v. Its derivative is given by u, derivative of v plus v, derivative of u. So if you consider this one as u and this one as v, then what going to be the result? First function is sin x, so derivative of second function, that is derivative of log x, is 1 by x, then plus log x second function, that is the log x, and derivative of first function, that is derivative of sin x, which is cos x. We know derivative of sin x is cos x. So now, so what we can do here, so from here we will find du by dx, that's going to be equal to u into sin x by x plus log x into cos x. So here you can replace this value of u here, you can put here this value. So then let me scroll down. Value of u is x to the power sin x, so let's put here x to the power sin x into sin x by x plus log of x cos x. Now similarly again with here, so let us consider v is equal to sin x whole to the power cos x. So again taking log, we will get log v is equal to log of sin x whole to the power cos x. So similarly, using the property of log, we will get log v is equal to cos x log of sin x. So again differentiating with respect to x. So again here you have to use the product rule. This is cos x one function, this is another function, log sin x. So log of derivative of log v will be 1 by v dv by dx, and on the other side first function is cos x, derivative of the second function. So if you assume this one as x, derivative of log x is 1 by x, but as it is sin x, so it will be 1 by sin x, and again derivative of sin x, because this is sin x, it is another function, not only x. So that's why again you have to find the derivative of that. So here it will be 1 by sin x, derivative of sin x, then plus second function is log of sin x, and derivative of the first function, that is derivative of cos x. So this implies, so 1 by dv by dx is equal to v on the other side. So here we can write cos x by sin x, yes, cos x by sin x, and here you see derivative of sin x is again cos x into cos x plus log of sin x, and derivative of cos x is minus sin x. So here it should be into minus sin x. So now what we can do here, so now dv by dx, so let us replace this value v by this value of v, sin x to the power cos x, sin x to the power cos x, and here it will be, here you can see this is cos x by this is sin x, and this is again cos x. So what we can do here, cos x by sin x is cot x, cot x into cos x. So this is cot x. Now minus sin x log of sin x. So I have written this function first before log of sin x. Okay, so from here dv by dx, okay, that's it, we can keep it here. So now how to find the dy by dx? Our aim is to find dv by dx, dy by dx. We need to find here dy by dx. So that's going to be du by dx plus dv by dx. So if you replace the value of here you see du by dx is this one, and dv by dx this is here. So if you put these two values, then here you will get x to the power sin x by x plus log of x into cos x plus sin x whole to the power cos x into cot x into cos x minus sin x into log of sin x. So this is our result. So this is the result of question number 9. So similarly we can solve question number 10. Now let us solve question number 10. So let me write here this. So this is question number 10. So let me solve this. Okay, so again here also you have to consider this one as u and this one as v. Okay, so let u is equal to x to the power x cos x. So if you take log on both sides, so what you will get, log u is equal to log of x to the power x cos x, and using the property of log of u is equal to x cos x log of x. So now we are going to differentiate. Okay, so differentiating with respect to x. with respect to x. So here you have to consider this is a product of three functions. Okay, product of three functions. Here we are going to apply this du ddx of u, v and w. So how to differentiate it? U v derivative of w plus u w derivative of v, then v w derivative of u. So we are going to apply this rule here. So derivative of log of u will be 1 by u du by dx. So let me scroll down the page. So then if you differentiate this as a product of three functions, then first two functions x and cos x, then derivative of second function, third function, that is log x. So this is suppose u and this is v cos x, and derivative of w, that is ddx of log of x, then plus u and w, that is x and log of x, derivative of the v. So here v is cos x, so assume this one as u v w. Okay, so then derivative of cos x, then again v w, then derivative of u, that is cos x log of x and derivative of x. So here you see du by dx will be u into x cos x, and derivative of log x. Derivative of log x is 1 by x, so here into 1 by x. So here x gone, then plus x log x, and derivative of cos x is minus sin x, so here we will get minus sin x, then plus cos x log x, and derivative of x is nothing but 1, so you can keep it like this. So here du by dx is equal to, so now let us replace the u by this value of u. Okay, x to the power x cos x. So then what will happen? We will get x to the power x cos x, and within bracket we will get cos x plus x log x. Here remember one more thing, let me write here, this sign will be minus, this is plus, this is minus, so plus minus minus, minus x sin x log x, you can write like this, and then also you can write here, okay, cos x log x. Okay, so I hope you have understood this. Now what we have, now let us take this part as v. So here v is equal to x square plus 1 by x square minus 1. So taking this one as v. Okay, so here we are going to apply the quotient rule, that is u by v. Its derivative is given by denominator, derivative of the numerator minus numerator, that is u, derivative of the denominator by denominator square, that is v square. So we are going to apply this here. So differentiating with respect to x. So dv by dx is equal to denominator, that is x square minus 1, derivative of the numerator x square plus 1, then minus numerator x square plus 1, derivative of the denominator, that means derivative of x square minus 1 by x square minus 1 whole square, denominator square, that is. So now let me differentiate. So here x square minus 1, and derivative of x square plus 1 will be twice x. So here we can write twice x, then minus x square plus 1, derivative of x square minus 1 is again twice x. So x square minus 1 whole square. So let us take twice x common from both the terms. So on taking twice x common, here we will get x square minus 1 minus x square minus 1 by x square minus 1 whole square. So here we will get twice x. So this one cancel, minus 1 minus 2. So here it will be okay, let me write twice x minus 2 by x square minus 1 whole square. That's going to be equal to minus 4x by x square minus 1 whole square. Therefore dy by dx, we need dy by dx, that's equal to du by dx plus dv by dx. Now we know dv by dx is equal to minus 4x by x minus 1 x square minus 1 whole square. So and du by dx is this. So using these two values here, what we're going to have, so our result will be, so du by dx is x square x to the power x cos x. So here x to the power x cos x into, so what we have, so here we have cos x and x sin x log x. So here cos x minus x sin x log x plus, and the third term is here cos x log x. So cos x log x, and dv by dx is minus 4x by x square minus 1 whole square. So this is our required result. Okay, that's how we can solve this. Now let's move on to next question, question number 11. So similarly again, consider this one as u and this is as v. Okay, so suppose, let me write here, solution question number 11. So y is equal to this one. So let u is equal to x cos x whole to the power x. Now taking log, so we will get log u is equal to log x cos x whole to the power x. So let me write here cos x properly. Okay. Now using the property of log, we will get x log x cos x, and again we know log of m into n is log m plus log n. Using this property, we will get here x log x plus x log cos x, and now differentiate both sides with respect to x. Differentiating with respect to x, we will get 1 by u. 1 by u is du by dx is equal to, so here to differentiate this we will use the product rule u and v. Okay, first function x, derivative of the second function, that is derivative of log x, plus second function, that is log x, derivative of first function, that is derivative of x. Then again here also we will use the same rule. So consider this one as x and this part as v. First function, second function, first function and second function. So then first function x, derivative of log of cos x, then second function log of cos x. so derivative of the first function, that is x, ddx of x. Okay, so if you differentiate those terms here, let me write one more step here. X into derivative of log x is 1 by x, then plus log of x, derivative of x is 1, so we will get log x only there, then x log of cos x. Now if you assume this one as log x, then you should get 1 by cos x. Then again you have to differentiate this function within bracket derivative of cos x, then plus log of cos x, and derivative of x is 1, so here we can write only log of cos x. So here x cancel, and okay, so du by dx is equal to u into 1 plus log of x plus x into, sorry, here you can write x into, and you see derivative of cos x is minus sin x, so let me make this sign minus, so minus x into sin x by cos x plus log of cos x. Now use this, replace this u by this value of u, so doing so what we will get, x cos of x whole to the power x 1 plus log of x minus x sin by cos is 10, so here it is 10x plus log of cos x. So now let's take the second part as v, this part as v. So here v is equal to, now v is equal to, we have here x sin x whole to the power 1 by x, x sin x whole to the power 1 by x, this one. Okay, so again taking log, okay, here log of v is equal to log of x sin x, this one, so 1 by x log of x sin x. Okay, so now let's differentiate it. One more thing, again if you use another property of log x, considering this one as m into n, then we will get 1 by x log of x plus 1 by x log of sin x. Okay, so now differentiate. Differentiating with respect to x, so that's log of v, its differentiation is 1 by v and dv dx. On the other side, here you see, you can consider this one as log of x by x. Okay, so then we will use this rule, u by v, derivative of u by v, that is equal to v derivative of u minus u derivative of v by v square. If we apply this, here we will get x derivative of log x, that is 1 by x, minus log x derivative of x is 1, so here we will get the numerator, and derivative of so here denominator square is x square. Okay, so here this x is the denominator here, and numerator is this log x. Okay, so then on the other side, again taking considering this one as log of sin x by x, so apply here this rule again, so that is v derivative of u minus u derivative of v by v square. So if you apply this here again, you will get denominator, that is x, derivative of log of sin x will be 1 by sin x, and derivative of again sin x. This is function of function, that's why minus. So let me clear this. Minus numerator, that is log of sin x, derivative of denominator is x here, so derivative of x is 1, so let's just keep it this way. Then derivative of denominator is square, that is x square here. So here you can see this x cancel here. Then so what we're going to have, dv by dx is equal to v into here 1 minus log of x by x square, plus here it will be x, derivative of sin x is cos x, so we will get cos x by sin x, derivative of sin x, isn't it, minus log of sin x by x square. So now replace this v by this value of v, then dv by dx is here this one, okay, x sin x whole to the power 1 by x, 1 minus log of x by x square, plus x, this is cos by sin, so it will be cot x minus log of sin x by x square. So here it also can be written as x sin x whole to the power 1 by x. Here we can take LCM, x square 1 minus log of x plus x cot x minus log of sin x. So this is dv by dx, and here we have got du by dx here. This is the du by dx. So using these two values we can find dy by dx. So dy by dx is equal to du by dx plus dv by dx. So we have got du by dx here, so use this value du by dx. So that is x cos x whole to the by x into 1 plus log x minus x tan x plus log x. Yes, so let me make a copy here, copy, then so this is the value of du by dx, this is du by dx. Then let us put this value dv by dx, let us put this value here, here. So then you will get, so let me write here, okay, plus let us copy this one again, so here is the dv by dx. So this is our answer, here is the required answer, that is dy by dx. That's how we can solve 11. So again here from 12 to 15 we need to find the dy by dx again. So here we have got different kind of functions. So again here also we have to consider this first part as u, this is v, so we can write, so let here u is equal to x to the power y and v is equal to y to the power x, so that u plus v is equal to 1. So here if you differentiating with respect to x, you will get d, so let me write here, du by dx plus dv by dx is equal to, and derivative of 1 is 0, so that's why here we will get 0. Okay, so this is suppose equation number 1, this is suppose equation number 1. Now let's find du by dx. du by dx. So derivative of, and we know u is x to the power y, so here it will be x to the power y. So before differentiating that, let me write here again, u is equal to u is equal to x to the power y. So in this case we need to take log. Okay, so here log of u will be equal to log of x to the power y is equal to, using the property of log, we can write y into log of x. Okay, so taking log okay. So now if we differentiate, with respect to differentiating with respect to x, so here it will be 1 by u du by dx. Then consider this one as first function and log x as second function. So here we will get first function y, derivative of second function, derivative of log x is 1 by x, so here it will be 1 by x, plus second function, that is log x, derivative of y will be dy by dx. So let me write here the way the page. So now here you can see, from here we can write du by dx is equal to, u into y by x plus log of x dy by dx. Now replace the value of u by this x to the power y, then you will get du by dx is equal to x to the power y y by x plus log of x to the power dy by dx. So if you multiply this term with these two, then what you will get, and let me remove the bracket. So here you will get, so this is x by, to the power y by x, that will be x to the power y minus 1. So here we can write x to the power y minus 1 into y, and here also we will get plus x to the power y into log of x dy dx. So we will get this one. This is suppose equation number 2. Now let us find now v is equal to y to the power x. If you take log on both sides, log v will be equal to log of y to the power x, and using the property of log we will get x log of y. So taking log, now differentiate. Differentiating with respect to x, so it will be 1 by v dv by dx. We know derivative of log v will be 1 by v dv by dx is equal to, here again you have to consider this x as first function and this one as second function. This is second function, this is first function. Use the product rule. Then first function x, derivative of second function, derivative of log y is 1 by y, then again you will get dy by dx, as it is not a function of x. Then second function log of y, derivative of x is simply 1, so keep it log y, and dv by dx is equal to v into x by y dy by dx plus log y. So if you put the value of v here, this value of v, and if you multiply with the term within the bracket, then what you will get, so y to the power x into x by y plus, again dy by dx, then plus y to the power x log of y. So here you can see, if you divide this term by this y, then you will get y to the power x minus 1. So here we will get x into y to the power x minus 1. Okay, so hope you have understood this. So now let us use these two values, du by dx and dv by dx, in equation number 1 here. Okay, so let me scroll down the page. Using equation number 2, and this is suppose equation number 3, dv by dx. Okay, and equation number 3 in 1. So we get, so what we will get, here you see x to the power y minus 1. So let me use black color. X to the power y minus 1, this one, into y plus x to the power y log of x dy by dx. On the other side, sorry, not other side, plus, then here you see this term, that is x y to the power x minus y dy by dx plus y to the power x log of y is equal to 0. Okay, now what to do? We have to separate the terms containing dy by dx, this term and this term. So first take dy by dx common from these two, dy by dx, that's going to be equal to, within bracket, here we will get x to the power y log of x plus and x y to the power x minus 1, then plus, if you transfer the remaining terms, this one and this one, on the other side, then what you will get? You will get minus x to the power y minus 1 by into y plus, and there also minus, sorry, here it will be minus y to the power x log of y. Okay, so from here we can find dy by dx, that's going to be equal to, let's take the minus sign common. So here x to the power, sorry, y minus 1 into y minus y to the power x log of y by x to the power y log of x plus x y to the power x minus 1. So this is our result. So this is our answer. So hope you have understood this, how to find. It's a very, now let us solve 13. Here taking log on both sides. Here we will get log of y to the power x is equal to log of x to the power y. Okay, now using the property of log, we know that log of m to the power n is equal to n into log of m. So using that property, x log of y is equal to y log of x. Okay, so here now differentiate with respect to x. Okay, differentiating with respect to x, what we will get? Differentiating with respect to x. So here on the left hand side, consider this one as first function and this is a second function. So using product rule, first function derivative of log y is 1 by y, isn't it? So we can write directly x by y. So log y is not a function of x, so again we have to write dy by dx here. On the other side, sorry, one more term left, then again plus second function, that is log of y, derivative of first function is x, derivative of x is 1. So now let's move on to right hand side. So again in right hand side also, taking y as first function, this one as second function, log x as second function, first function is y, derivative of log x is x, 1 by x, sorry, so we can write y by x, then plus second function log of x, derivative of y is dy by dx. dy by dx. Now take this term to the other side of the equal sign, then and taking dy by dx common, what we will get, x by y minus log of x, and other terms to right hand side, this one to right hand side, we will get y by x minus log of y. Okay, so here you can see, so dy by dx will be equal to y by x minus log of x, and here x by y minus log of, this term should be y. Here we have to write log of y, and here x. So if you multiply both the denominator and numerator by xy, then what you will get? So here you will get y square, or you can do one more thing. Okay, instead of multiplying this, what we can do, just take LCM. Here in the numerator x will be the LCM, y minus x log of y, and here at the denominator y will be the LCM, so x minus y log of x. So let me write it clearly. By y. So this can be written as, so dy by dx is equal to y into y minus x log of y by x into x minus y log of x. Okay, or you may write this one as like this, y by x. If you take both from both numerator and denominator, from the both numerator and denominator, if you take minus 1 common, then you will get x log of y minus y, and here log of y log of x minus x. So that's how also you can write. So both now let us solve question number 14. Here taking log, we will get log of cos x to the power y is equal to log of cos y to the power x. Then using the property of log, we will get here y log of cos x is equal to x log of cos y. Now differentiate this, differentiating with respect to x, differentiating with respect to x. Now here you see, consider this one as first function and this one as second function, use product rule. So that in that case, first function, derivative of the second function, derivative of log of cos x. Okay, now here you see, if you assume this one as log of x, then derivative of log of x is 1 by x. So instead of x there is cos x, so it is 1 by cos x. Again you have to differentiate it, ddx of cos x, isn't it, as it is another function. So here we will get 1 by cos of x, derivative of cos of x, then plus second function, that is log of cos x, derivative of the first function is y here, so we will get dy by dx on the other side of equal sign, right, on the right hand side also. So assume this x as first function and this one as second function. So use the product rule again, first function x, then derivative of the second function, derivative of log of cos of y. So in this case, again if you consider this one as log of y, then you have to write 1 by y dy by dx. Again you see y is nothing but cos y, so again you have to write here dy by derivative of cos y again and dy by dx. Okay, so instead of writing this, let me write directly here this result, 1 by cos y derivative of cos y, then dy by dx. Okay, so hope you have understood this. Plus second function, that is log of cos y derivative of first function is x, derivative of x is 1 simply. So here we know derivative of cos x is minus sin x, so here it will be minus y by sin x by cos x, then plus log of cos x dy by dx is equal to minus x. We know derivative of cos y will be minus sin y, that here you see, by cos y dy by dx plus log of cos y. Okay, so I hope you have understood this. So here you see minus y, this is 10x, because we know sin x by cos x is 10x, plus log of cos x dy by dx minus x again 10y sin y by cos y 10y, isn't it? So dy by dx plus log of cos y. So from here what we can write, so here you see yes, so take the term containing dy by dx on one side of on the same side of the equal side, then let's see what will happen, what we will get here. So from these two terms, take these two on the same side of the equal sign and take dy by dx as common. So dy by dx is common now, so within bracket we will get log of cos x plus x 10y. Okay, then on the other side of the equal side, so if you transfer this to on the other side, this term on the other side, then you will get log of cos y plus y 10 of x, then dy by dx will be equal to log of cos y plus y 10x, then log of cos x plus x 10y. So this is the answer of question number 14. Today we have solved question number 9 to question number 14. So I am not going to complete the exercise here because video will be too long. So remaining questions from question number 15 to question number 18 will be solved in the next video, part 3. Very soon I am going to upload that part. Okay, so we will complete the exercise in that video. So thank you for watching. If you are new to my channel, subscribe the channel, and if you like my videos, then share with your friends and help me to grow my channel. Thank you.